Hello, Science 10, and welcome to your fifth lesson in chemistry. Today, we're going to be talking about ionization and what that means, and what does a full octet mean? How do ions have an imbalance of electrons and protons? How to draw energy level diagrams for ions, and how to name ions. So let's get started with the generalization of what is ionization. Essentially, when we have been looking at things so far, we've been looking at a neutral atom. Oxygen has 8 protons and 8 electrons. I know this because that's its atomic number. It's a neutral atom. It has no charge. However, atoms want to have full octets on its outer shell. So a full octet means 8 valence electrons. And it wants that because it creates the greatest stability for that atom. So what ends up happening is atoms will actually gain or lose electrons to become more like noble gases. So if you think about noble gases, that outer shell is always full. When an atom gains or loses an electron, we say it becomes ionized, or this configuration is called ionization. So going back to my oxygen example quickly, if I know I have 8 protons and 8 electrons, I know the energy levels for oxygen is the first energy level has 2, and the next energy level has 6, because 2 plus 6 is 8. But for oxygen, that's not stable enough. Oxygen wants more electrons because if it has 2 more electrons, it has a full outer shell. So oxygen becomes ionized by gaining electrons and filling its outer shell. When we fill the outer shell, this changes the atomic charge. Originally, it's neutral, 8 and 8, so 8 protons and 8 electrons make 0. But as soon as I gained 2 negative electrons to the oxygen atom, I all of a sudden became unbalanced because I have now more electrons than I do protons. And remember, electrons and protons have charges. So if I gain 2 negatives, I am 2 negatives more than what I was originally, so I become 2 negative. So oxygen has a charge of 2 negative. If I was to lose an electron, I now have 1 more positive proton than electrons. I become positive. So again, losing and gaining electrons results in ions having imbalances in charges. One of the ways you can find out what your ion's charge is to take the number of protons you have and the number of electrons you have in the ion and subtract them, and you'll get the charge. So what I'm going to do is show you an example of ionization using Bohr diagrams and showing you how it has a stable structure or not stable structure. You don't really have space in your notes to add these, but you're welcome to just put them off to the side. You're going to fill in a chart afterwards. You don't have to do the drawings. You'll just more or less do a chart. But I'm going to show you with a visual first. So here is fluorine. Fluorine has 9 protons and 9 electrons. So if we count 2 in the first shell, and then 2, 4, 6, 7 in the second. So 9 electrons overall. Fluorine, though, is not stable in this configuration. It is neutral because it has 9 electrons and 9 protons, but it doesn't have a stable octet. That outer ring isn't full. So what ends up happening is fluorine will go from this structure to gaining another electron and becoming fluorine with a negative charge because I gained 1 negative electron. So the fluoride ion, we call it, has 1 more valence electron and now has reached its stable octet. So it went from being a neutral atom with 9 electrons to a stable atom with 10 electrons. But now I've changed the charge of fluorine. Here it is neutral, but here I've gained a negative, so I have to show that I have a negative electron added to fluorine. And that's how come fluorine has a little negative charge here. All right, let's do another example. Sodium. Sodium normally has 11 electrons because it has 11 protons and 11 electrons. Again, this configuration right here is not stable. It has 1 loner valence electron on its outer shell. Now, unlike fluorine, who was able to gain an electron, sodium would rather give it away because it's way easier to give away 1 electron than it is to find somebody to give you 7 electrons. So what sodium does is exactly that, is it gives away its outer electron. So now sodium in its stable octet instead of having 11 electrons, now has 10. So we now see sodium is positive because it has 11 protons, one more positive than it does negatives, because it only has 10 electrons. So that is how we have the sodium ion becoming a positive ion. In your notes, you have a chart that shows the symbol of the element, lithium, oxygen, phosphorus, and calcium, along with its charges. I want you to start by filling out its protons, its neutrons, because remember, it's just atomic mass minus protons gives you your neutrons. And then I want you, using the charges shown, come up with how many electrons you think each one has. All right, so moving on, we're going to talk about how to now draw these. So I showed you drawings as Bohr diagrams, but Bohr diagrams take a long time. So we're going to just draw them as energy level diagrams. So when drawing an energy level diagram for an ion, the first level is always identical. So level 1, unless we're talking about hydrogen, but don't worry about that, we won't be, or helium. We'll just use bigger examples. However, the electron number and the symbol will change, as the symbol now must show the charge of the ion. So in your example, you have fluorine. So here's fluorine as a neutral atom. Just fluorine, 2 electrons, 7 electrons, for a total of 9, much like my example I showed you earlier with the Bohr diagram. However, fluorine is not stable. It wants to take another electron from somewhere and make it a stable octet on the outer level. So when it's happening, is it borrows an electron from someone. And now its outer shell has 8 electrons right here. It is stable, but fluorine itself now has a negative charge. So the first level is identical, 2 electrons in the first energy level. I changed the amount of electrons in my second energy level because I needed to gain 1 here for a full octet. But I also remembered to change my charge on my symbol. And that is how you show an energy level diagram for ions. So let's do some examples from our notes. We're going to start with the ionization of magnesium. So here is magnesium as as a neutral atom, Mg, and it has 12 electrons and 12 protons. So I have 12 there, 2, 10, 12. But again, magnesium is not stable. So looking at its outer level, you have to think to yourself, okay, if I have 2 electrons, is it easier to lose 2 or gain 6? Hoping you're saying it's easier to lose 2. So in order for magnesium to be an ion, it has to lose 2 electrons. In doing so, it becomes positive, and it becomes positive by 2, because now we have an imbalance of protons to electrons. I now have 12 protons, 12 positives, to 10 negatives. So I have 2 positive extras. So I changed my Mg to my symbol with my charge, and I'm showing here my energy level diagram. So let's try nitrogen. So nitrogen has a protons and electrons of 7. So here it's a neutral atom. I want to ionize it. So again, look at the outer level. Is it easier to gain or lose? Is it easier to gain 3 or lose 5? I hope your answer was gain 3, because it's easier to find 3 than get rid of 5. So what ends up happening is nitrogen takes on 3 electrons, but in doing so, it changes its balance again. It's no longer neutral. It now has 3 extra negatives. So now it is 3 negative. So that is how you draw energy levels for ionization. But let's kind of just talk about ions in general, because I've called them a couple different things. I've said things like the fluoride ion or the magnesium ion. Their names are not the same. So let's talk about why that's happening. So ions are essentially an imbalance or unbalanced amount of protons and electrons, which we have talked about earlier. There are these things called cations, and they are positively charged. So cations are the positively charged, and they're positively charged because they've lost electrons. Reminding yourself that losing electrons means we're losing negative things, so we're going to be more positive. The other side of the story is negatively charged ions are called anions. So please make sure you write down these two because these definitions are important. Cation and anion. An anion is negative because they've gained electrons. All right. So that's some of the language we're going to be using as we move forward. Again, to figure out the charge of an ion, it's essentially your protons minus your electrons equal your charge. So if you have 8 and 10, 8 minus 10 is -2. If you have 12 minus 10, then it's +2. All right. Don't flip it around to put the biggest number first. Always just take protons minus electrons or look at your periodic table. So the cool thing is if you look at your periodic table and you look to the left hand of the staircase, you'll notice that all metals are actually cations. They're all positive, and all nonmetals are anions because they gained electrons. So your periodic table actually tells you a lot of information. Now, the key part to this, though, is that we have to name them differently. So a metal or a cation naming will just be the element name such and then ion. For example, sodium is just called the sodium ion because it's a positive ion, so we just call it the sodium ion. It's a little bit different for the negative ones. For the negative, it's element name "ide." So if you remember ionic naming, we always added an IDE ending, same with my molecular, same idea here. Element name IDE ion. So for chlorine, for example, because it's negative, we would call it a chloride ion. For the chemical symbol of an ion, please make sure that you are showing your positives and your negatives with your numbers, okay? So examples are magnesium 2 plus, aluminum 3 plus, and sodium 2 negative. Always remember to put the positive or negative symbol. You have to have it there, but if there's a charge, so like the twos, the threes, put the numbers before your negatives or your positives. So that is ionization in ions, and I hope you guys figured out what does ionization mean, what does full octet mean, how do ions show an imbalance of electrons and protons, how do we draw them, and how do we name them. I hope you have a great night, and if you have any questions, please let me know.